consider the reaction between magnesium and hydrochloric acid to form magnesium chloride and hydrogen gas. When the concentration of hydrogen is increasing at 0.32 molar per second, what is the rate of depletion of hydrochloric acid? So when you get this kind of question, first and foremost you need to write the balance equation for the reaction. So this reaction is between magnesium and also hydrochloric acid to produce magnesium chloride and also hydrogen gas. So the first thing that you need to do is you need to balance out this equation. So you do have 2 chlorine over here and 2 hydrogen over here, therefore you need to add 2 here. So once you already have the balance equation here, you need to write the rate expression. So the rate expression is equivalent to, for magnesium is negative because it is at the reactant, so negative delta concentration of magnesium over delta T is equivalent to negative 1/2 concentration of HCl over delta T is equivalent to positive delta magnesium chloride over delta T is equivalent to positive delta H2 over delta T. Alright, so if you look back at the question, you were asked to calculate what is the rate of depletion of hydrochloric acid. So the rate of depletion of hydrochloric acid, this is the one that you need to calculate, and then given to you in the question is the concentration of hydrogen is increasing at the rate of 0.32. So hydrogen is given to you. So it means that delta H2 over delta T is actually equivalent to 1/2 delta concentration of HCl delta T, whereby this is equivalent to 0.32 given in the question is equivalent to delta HCl over delta T. So what do you need to do is that you just want this, the value for this, so you need to bring this up. So delta HCl over delta T is actually 0.32 times 2, so you shall get 0.64, so mole per second. So this is the final answer for question number 2. Question number 11. A second order reaction involving reactant initially at 0.1 mole per liter and found to be 20% completed in 40 minutes. Determine the half-life in liter mole per second for this reaction. So given to you is the initial concentration, and it states that it will be 20% completed in 40 minutes. So since the half-life, you were asked to calculate the half-life in second, so the 40 minutes needs to be converted to second. So duration of 40 minutes need to convert to seconds. So 1 minute is 60 seconds times 60, so you should get 2400 seconds. And then it states here that it was 20% completed. So in the question it states that after 40 minutes it was 20% completed, whereby the initial concentration is actually 0.1. So 20% from 0.1 is equivalent to 0.02. Therefore, initial concentration is 0.1. The thing that already completed is 0.02. So the actual, the 80, which is the final concentration that you have, is actually 0.08 mole per liter. Alright, So since this reaction is following the second order reaction, so we are going to use the formula for second order reaction. 1 over AT is equivalent to KT plus 1 over A naught. So your KT is actually this figure and your A naught is this, and the time is given in the question, which is 40 minutes, so you already converted to 2400 seconds. So all you need to do is plug in all this value inside the formula. So it's going to be 1 over 0.08 equivalent to K, T is 2400 plus A naught, which is 0.1. So from here you should get K is equivalent to 2.5 over 2400, and K shall be equivalent to 1.0417 times 10 to the power of negative 3. So this is the final answer for this question. Okay, we have reached our final question, question number 12. The reaction between ethyl ethanoate and also potassium hydroxide follows the second order reaction again. So the aqueous solution containing equimolar amount of ethyl ethanoate and potassium hydroxide will mix at 298 Kelvin. Initially, the concentration of KOH was 10 molar. At 300 seconds, the concentration of KOH remaining was 6.25. Calculate the half-life of this reaction. So this question is actually almost the same as the question number 11. So all you need to do is plug in all the values. It's easier in this question actually. So the value, the formula for second order reaction is 1 over AT is equivalent to KT plus 1 over A naught, and you need to like directly put the value because it's all written in the question. So the AT is equivalent to 6.25, K is the thing that you want to calculate, T is already in second, and 1 over A naught, the concentration, the initial concentration is 10. So from here you shall get 300K is equivalent to 0.16 minus 0.1. So your K is equivalent to 0.06 divided by 300. So K is equivalent to 2 times 10 to the power of negative 4. Okay, and then you were asked to calculate the half-life. So the half-life for second order reaction, so half-life for second order reaction is equivalent to 1 over K times initial concentration. So you already know the value of K. So 1 over 2 times 10 to the power of negative 4. The initial concentration is actually 10. So the final answer for the half-life is actually 500 seconds. Alright guys, so this is the end of this week's video. So I hope you can understand how you should tackle all the questions from chapter 1 till chapter 3. And I wish you all the best for your test 1, and I'll see you again next week. Goodbye!